What are the best practices of test automation maintenance and how to make our automation framework maintainable? Before going to that, we need to understand what is maintenance mean to test automation frameworks. So in general, yeah, if you're thinking about Selenium or APM as your framework, that will be maintained by a lot of contributors, and they are actually looking into it, and they are keep improving, they are adding features, removing features, whatever they can do, right? What we are talking about test automation maintenance is pretty much the maintenance of the framework or the tool actually you created using these frameworks for your company, so that you have full ownership. That is what you need to maintain, which means your endpoints are keep changing, your UI is keep changing, your mobile application might be changing, some of the features will be added, removed, changed. Whatever happens, you have to catch up on all these changes. So how you are going to catch up on all these changes, at the same time also add the new test cases, but in general there is always this question of like, what is the test automation coverage cover, how are you going to improve your coverage? These are all the basic questions you will be get asked all the time. So you have to think how you are going to maintain this automation framework with all the changes, all the possible changes can happen in your libraries, in your applications, in your system environment variables. The other point of maintenance, the reason for maintaining it, it's because it has to be multiple people need to or able to work on this framework. It's not just one person developing and running it forever. It's something that the developers wanted to contribute to. Some other QA members will be joining your team, and you will be expanding your QA team into like 1 member to 5 member to 10 member, 15 member. So it will be keep growing. The team size will be growing. The automation framework coverage, you start with 10 sample test cases and then it becomes 100, thousands. So it is also keep changing. So you have to think what is maintenance means to you, how you are going to catch up these changes. So the general idea I would do is I would always split very clearly, very have a very static distinguish between the definitions and tests. So the definition is something like, imagine a login page, what the field name, what is the field, what is the field name is stored in, which variable this field is stored in. These are all in a definition class. You will be having it in, I know, Python, Java, whatever you call it, or I mean, a lot of people will be using Java page factory. This is something like a factory model, right? So you store all this information into a class so that you can maintain it. You can change it at any point and you want. So that is what I call it as a definition file. Make sure your definition file is segregated from your test file. Your test file, it shouldn't be having all these references. It shouldn't have all these test data. It shouldn't send some values from test to the function. The test function, the test files will be very clear that it only follow through exactly what the steps you are doing. It's not doing the data, it's not doing the identification of these fields. If you think this page, or after doing this transaction the page has to wait for like 30 seconds, don't do it on the test file, because the service might change, the service might improve, the 30 seconds might reduce into 10 seconds. What if the it gets worse, the 30 seconds change it into 1 minute because of business reasons? So these are all the things, these are all the external factors outside your testing. Think of your test script as a test case, exactly like a test case. What are all the steps will be there? If you look at a test function, you have to see the same steps. The test data, it has to be in a separate area, and the definition should be in a different area. Test will be in a different area. All of them are interconnected. You can structure it in any way. You wanted to do it into multiple folders, fine. You wanted to do it into multiple files, different classes, fine. It doesn't matter. It doesn't matter how you store it. All you have to care about is you store it separately, and it's all interconnected using inheritance or some way. You are using those definition file, you using those test data files into your definition files, then you use those definition files into test files. If you have these three-step distinguishable differentiation of your automation framework, then it becomes more easy. Why? Whenever there is a UI change, you don't have to change your tests, you only change this. When the data changes, or when there is a basic event happened and some QA environment need to be cleaned up and all has to be gone, that's what you do. You just replace the test data file with what you wanted to do. And another idea or another recommendation I would do, a lot of people using, when they think about test data, they always think about a data store, something like, an SQL database or a Excel sheet or a CSV file. My recommendation, I mean, it's kind of odd. I had a lot of conversations around this, but my recommendation is, don't do this static test data in files. Always store this information into your classes. Make it into your, it's part of your file. It's part of your GitHub um, tracking record when the test data is changed from one value to another. The only difference, only variables which is makes sense to store it in a file is your secret credentials. For example, if you imagine the same login page, the login username should be on, username and password can be, the credentials can be on an environment file. Don't do it on a CSV file, but do it in an environment file, which any library will automatically load at time of execution. So same thing for Python, you might add a n file. TypeScript, you do it in a .n file. Same as ever, right? So these .n files, make sure it only has secret data. Anything non-secret, anything is available. For example, a API URL, or UI information, or the text you are doing for. All this information, a static test data, static checkout ID you are using it for. Whatever non-secret values, always make sure, or my recommendation, always to keep it inside the GitHub repository so you have a clean track record. There is some cons in this approach. The reason is, like, sometimes multiple people wanted to change different test cases and then they need to change different test data. This might be little bit burden to edit it or do it on the repository itself. But that is also a good thing, because you have a track record of who changed what at what time, for which reason, or for which PR they actually changed this test data from X to Y. If it is only in database or a key value store, all you would be seeing is pretty much all the testers wanted, they just change the test data or the table in the same way, and then they simply upload their scripts, and their scripts work on their local and your script work on your local. When you try to merge, or when in the PR, it might not work. So there will be a lot of other things. How you can change it, you have to keep multiple SQL files, or multiple SQLites. So there are like pros and cons of every approach. These cons is very low compared to the pros it provides us. So this is what I would say. Split your definition, data, and test into three different sections. Clear, differentiate sections. Maybe in a class, even if it is a class, three different classes, create folders. Put some folders and then do it. All the utility functions and stuff, don't consolidate with your definition classes. Whatever you don't need it in the definition, whatever it's not specific to your application, put that into a separate class as a utils folder. In the utils folder, you generate that, you generate this, you do a datetime function, whatever manipulations you wanted to do, you put that into a separate utility and use those utilities in your definition classes, and then use the same thing on all the same thing from the definition class to test. It will also give a clean hierarchy as well as clean dependency. At the same time, it's all good enough to work individually, independently, and autonomously. That's my recommendation.